Hey guys, here's a 3D scan of a water canister a viewer sent me. He wants a lid cover that fits the spout, and since it's got a cusp curve, it's a bit of a challenge to model. This scan came from the river point in Spy 2. There is a bit of noise around the edges, but since the lid isn't meant to be super tight, just to cover the canister and keep smells in, I will leave about a millimeter gap all around. That way it will fit fine even with a rough scan. I will also add an overlap wall that goes about 3 mm into the canister. That way the lid lines up easily and does a better job trapping the smell. For this demo, I'm jumping into Autodesk Inventor and I will build the whole model with just 3 commands: patch, stitch, and extrude. Here's the point cloud. I drop a sketch on the XY plane, drew a 3-point arc to find the center, and then an arc at the spout tip to see if it's lined up with the x-axis for milling. If it's off center, no worries, I can just tweak the position in the Edit Point Cloud menu. Alright, next step, I drop a sketch on the XY plane and trace the canister's edge with a mix of arcs and lines. The next step, I offsetting the edge out 3 mm so the lid overlaps the canister profile. The next step is dropping a sketch on the XZ plane and tracing out the canister's side profiles. Next up, I will make a 3D sketch so I can build the intersection curve. Then I run the intersection curve function, which gives me a 3D line right where the two sketches meet. Then I just mirror those 3D lines over to the other side. So now we have got our first 3D line profile for the lid. Then I go back to the side sketch and offset the profiles 2.4 mm. That gives the lid its thickness. I made the intersection curve and just mirror it over to the other side. Since the lid's contact face needs to be flat, I throw in some straight 3D lines to keep it flush with the canister. Then I just run the patch command, pick the boundary lines, and it fills in the patch surfaces. The top of the lid doesn't have to be flat, so I throw in a spline and pull up the control points to shape those curves. Then I patch this surface the same way I did with the last profile. And if the curve looks off, I just go back, tweak the spline control points, and keep adjusting until it feels right. Then I drop in some 3D lines on the side edges so I can patch those surfaces too. This way, the whole thing is watertight and ready to turn solid. Alright, with the watertight surfaces ready, I just select them, hit stitch, and it turns into a solid. The color chips to show it's done. Now I'm making the overlap wall that fits down inside the canister. I create a new 2D sketch on the XY plane and offset the canister's profile edge by 1 mm. I take the same size sketch and make a 3D intersection curve from it. Then I offset the wall profile at 2 mm and make another intersection curve. So now I have got 2 curve profiles for the bottom of the wall. Now I'm adding 2 more wall profiles near the lid face using intersected 2D sketches. So I throw in a few 3D lines to give me the boundary I need for patching the side wall. Now I start patching the surfaces. Just a head up, You can't merely patch surfaces or the solid won't work, so you have got to patiently patch all four sides one by one. Now that the surfaces are watertight, I just run stitch and it turns into a solid. At this point, I have got two solids body, so I just run combined to join them together. Let's switch the point cloud back on to check for collisions. Looks good, no crashing, so this lid should fit the canister. Last step, I just fillet the sharp corners. Basically, look for any sharp curves and round them up. Next, I make a knob handle. Just sketch a circle on top of the lid and extrude it with a taper. The lid modeling is now complete and ready to be exported for 3D printing. In Creality Slicer, I orient the lid vertically. This minimizes the need for support structures and improves overall print quality. In certain areas, I need to manually paint supports to ensure proper printing. Before I hit print, I always scroll to the layer to spot any weak points. And here's the print, finished in just about an hour and 20 minutes. Cusps curves are a bit tricky. You can only get them by surface modeling with intersection curves from two sketches. The wall that fits into the canister takes a bit longer. You have got to build it with patched surfaces. Alright, that's it. Hope you pick up a few tips. Thanks so much for watching.